So now I replace IE2 with that equation.
Would it be beta 2 plus 1?
Sorry. Beta plus 1 times IE2. So IB2 is IE1, so I'll replace that. That would be IE2 is equal to beta 2 plus 1 times IB2, which is IE1. That would be beta plus 1 plus IB. And that IE2 is actually IE for that device, that new device that I invented, right? So there you go. This is kind of the same as a large beta plus 1 for that new transistor. So with some approximation, I can say, so you have to do this all the way. So you have to say beta 1, beta 2 plus beta 1 plus beta 2 plus 1. And if I say this is relatively small compared to beta 1, beta 2, the beta of that transistor would be beta 1 times beta 2. It's not accurate, but it's close. Okay?
So this provides like a significant current amplification.
Exactly. So what happens is that getting a beta of 100 out of each BJT is relatively easy, right? So 100 here, 100 there. What do you get for the Darlington pair? 100 times 100. That's 10 to the 4. You get a BJT with a huge beta, which is really good.
But there isn't a CMOS equivalent, is there? Like, would there be a Darlington pair for MOSFETs?
There are Darlington, no. I mean, because there is no use for it.
Okay.
Okay? Now, there is one use for it for, like, they do pairs of BJT with CMOS. So they put a BJT here and a CMOS here.
So that way it doesn't consume current.
Any current. So it gives you the benefits of a BJT plus the benefits of CMOS. Those exist. Yeah.
What is it called?
It's the technology is called BiCMOS.
So then how do IC and IE relate? Are you talking about like your device
The new device, you just played with this, I don't know. It's going to come out to be this, beta 1 times beta 2 is going to show up. And therefore you can kind of say, okay, this is a device with a beta of almost equal to beta 1, beta 2. It's not accurate, but it's a pretty good approximation. So now what you could do really when you do the small signal model for that specific question, you can actually turn it into one model and put beta 1, beta 2 here. Now, about R pi, you got to be careful. The R pi of this thing, what is it? There's actually another R pi in the emitter of this thing. So we just talked about it, right? We said if you have an RE, it's going to get multiplied by the beta plus 1 of this one and shows up at the base. So this R pi for that model would be R pi 1 plus beta 1 plus 1 of R pi 2. Okay? So it actually gives you a lot of benefits in terms of the input resistance of that thing too. Now, all that aside, if you don't care about any of these approximations, I don't necessarily want you to memorize any of this thing. Let's just draw the small signal model of this circuit, which was your original question. But that was something that is useful. So the small signal model, you still have the two. So you have your source, and you have your capacitor. It's going to turn to a short. So I'm going to leave it there, and then I'm going to draw the BJT models, twice. There's this, and that's what I want you to do. Draw the BJT models first. Somewhere, doesn't matter where. You have two BJTs, draw two BJTs. Okay? And then call that R pi 1, R pi 2, beta 1 IB1, beta 2 IB2. Can you do this? Okay.
Yes.
Now start connecting them to each other with the rest of the circuit. So you come from this thing that is grounded with Vs, and you come and look, and you see that it's connected to the base of the first transistor. So you immediately do that. And you see that it's also connected to R1. The other side is a power supply for AC analysis is a ground. There's another resistor. The other side is ground. So that would be your R1 and R2. So you're done with the first one. Then you come to the emitter of this first one, and you see that it's connected to the base of the second one. So you go there and connect it to the base of the other one. And then you see that the collector of the first one is connected to the collector of the second one. So you go there and connect the two to each other. Okay? And then you say in the collector of both of them, there's a resistor gets connected to a 10 volt, that's a ground. So that's your 2.2K. And then the emitter of the second one is connected, it's actually shorted to ground because there's a capacitor there. And you're done. That's how you draw any small signal. So when you start, just start with the model for the transistor. If you have one, draw one. If you have two, draw two. Now, in this case, you have two that are kind of connected to each other, so it makes sense to do it this way. For some of these, like the last one, I wanted to actually do the last big